Swayam Prabha. Digital India. Educated India.
Good morning, everybody. So far, we are discussing varieties of vacuum pumps, positive displacement pumps and momentum transfer pumps, etc., watering pumps, steam jet ejectors. In the last 30-40 years, parallel to these medium, high and ultra-high vacuum pumps based on conventional routes, there is a parallel effort going on in the industry to realize dry vacuum pumps. This dryness is very important. You may get at the end of the story a 10 power minus 7 torr using one rotary pump and diffusion pump. But the final vacuum that you are getting at 10 power minus 7 torr, if you chemically analyze it, it will have some traces of hydrocarbons which are there in the diffusion pump oil or rotary pump lubricating oil, etc. With high tech in semiconducting devices or pharmaceutical sectors, that to high tech pharmaceutical sector, even in food processing, even in high tech metallurgy, very ultra pure materials are made, etc. Even in analytical instruments where you are analyzing the chemical composition, in such applications, they not only want ultra high vacuum, they also want a dry ultra high vacuum. Dry ultra high vacuum means you should not have any traces of lubricating oil. That means we should produce pumps right from atmosphere up to the ultimate vacuum that is required for an application using vacuum pumps which do not employ any lubricating fluids. So, these are known as dry vacuum pumps, and its importance I already told you, it is growing up and up, because even if 10 power minus 5 torr is made, if it is not having oil traces, it is a good vacuum. You may have 10 power minus 7 torr with hydrocarbons. So, in some semiconducting device manufacturing, if that impurities go and settle and interfere with your process, or that pharmaceutical sector, if it is interfering, it is not allowed. So, the hydrocarbon contamination or even any other contamination which interferes with your process, chemical contamination, is not allowed. For such reasons, there are very good quality dry vacuum pumps being developed in the last 40 years, 30-40 years, and today the technology is quite matured. Broadly speaking, these devices operate on similar principles, but they have an additional problem to be solved, that is, without lubrication, how to take care of the friction, etc., wear and tear, that is all. There are 4 major pumps in dry technology. One is diaphragm pump, the other is claw pump, then screw pump, then scroll pump. Different pumps have got different qualities, different pumping capacities, different downtimes, different industrial compatibilities. That we will see when we are discussing process applications, how to select among these, or should we select them at all? Should we not select only rotary pump? If it is -2, should we not select only diffusion pump? So, these 4 pumps are medium dry pumps. Vis-a-vis medium wet pumps are there, piston pump, rotary pump, steam jet ejector, water ring pump, like that. There is one pump which is common for all these fellows are roots blower. That is also a dry pump. It was acting like a booster to all those wet pumps. Now it can be used to boost the vacuum level or pumping speed of these dry pumps also. That's how roots blower continues with this dry pump technology also for boosting applications. This is up to medium vacuum, -3 maximum, which are good enough for very good high-tech applications like molecular distillation, food processing, etc. But if you want semiconductor applications, space applications or nuclear applications, you have to use ultra high vacuum. They should also be dry. So diffusion pump also cannot be used. So people started developing new technologies called turbomolecular pumps, ion pumps, cryo pumps, adsorption pumps, etc. These are dry, high vacuum, ultra high vacuum pumps. There are dry, medium and low vacuum pumps. So we will start this dry story, but the story is not dry. It will be quite interesting. These dry pumps, how to take care of various challenges. We will start our story with a pump called diaphragm pump, which is a dry pump. I will not give this introduction to the other pumps because dry requirement is same for all of them. So these 4 pumps, diaphragm pump, scroll pump, screw pump and claw pump, we will see in medium dry vacuum conditions. And later in the next session, we will also go for turbo and cryo, etc., ion pumps. Okay. Coming to diaphragm pump for today, the concepts being covered in this lecture are introduction to diaphragm pump, construction of diaphragm pump, the physical working principles behind this 2-stage diaphragm pump, and the characteristics like pumping speed, etc., throughput of these diaphragm pumps. Finally, we will touch upon uses, advantages and limitations. These uses or other name is applications. We will anyway deal when we are going for applications, process applications, we will again come across same concepts, but that time we will concentrate more on application rather than pump. But there are some process related constraints on the selection criteria of vacuum pump. That also you should know under system design. So these are all related. That's why I talk sometime application, sometime design when you are discussing production. So tomorrow we may have to do something with measurement also. The same gauge, when you are having same pressure, some other gas is environment, it will measure some other vacuum. It is a wrong value. From molecular density point of view, a pure definition of pressure, it is wrong. So we will see those things little later. So coming to this diaphragm pump, this is a positive displacement pump in a way. And if you look at the figure, it looks like a typical mechanical device, crankshaft and cam and housing and piston, exhaust valve, inlet valve. These are there in IC engines, also for compressors and various other applications that we see in our day-to-day life. It is somewhat like that. It is a mechanical device. Okay. It also involves compression and expansion. And in vacuum technology, we know that already compression expansion is used to produce vacuum. Small increase in volume plus the total volume of the process keeps on increasing. So that way there will be suction and that will be positively displaced. You isolate a volume, sweep it, compress it, exhaust it. This is what we have seen in rotary vane pump. But similar operation is done here also, slightly different here. Same volume is exposed to inlet valve for some time, same volume is exposed to outlet valve sometime, like our IC engine type. Okay. Whereas in rotary vane pump, the sweeping volumes, inlet volume, that is expanding volume and compressing volume are 3 different. Here it is slightly different. And second point is, this is a dry pump. Dry pump means free from lubricating oil, ideal for pharma applications. At that time we use pump as a dry pump. It is also ideal for ultra high vacuum applications. There we are not talking as a process pump. Process pump means it is doing the main duty of evacuation which is needed at that pressure that process is going on. Whereas in high vacuum requiring dry pump of this sort in a different application. It is a backing another complicated, another high-tech dry pump, that is turbomolecular pump. So, this dry pump can do two purposes. One is by itself it will be a process dry pump, or it will act like a good dry vacuum pump to another ultra high vacuum dry turbomolecular or cryo pump. Why should we do that backing? Why can't we do some rotary pump? Because it depends on the history of evacuation right from atmosphere, how this chamber is being evacuated. Turbomolecular pump or diffusion pump, high vacuum pumps will not work unless you bring to -2 torr using some other medium pump, medium vacuum pump. Just like we have seen rotary pump brings to 10 power -2, afterwards diffusion pump takes over. And if you want to use boosting or something for backing applications, in between rotary and diffusion you put a booster. And if you are satisfied with -3 torr, forget about high vacuum. All these combinations we have seen already. Here also the history of evacuation is important. The first pump which is going to evacuate your chamber is not the turbo pump. It will be bypassed by this dry pump. We will see when it comes to system design various applications, particularly semiconducting device applications, how it is to be done. There are lots of protocols, how we are going to operate, sequence of operation. Now it is automatic. There is a lot of IoT is there, and so you have to be careful in choosing a pump, choosing a process, choosing an instrument, designing proper piping, designing proper capacities, and also quality. Quality here we are talking is dry pump. Now, what is the ultimate vacuum that you can get here? Only very not much vacuum, but that is a dry pump. Rotary pump can do 10 power -3. This pump only can create 0.1 torr, but we require this. Turbomolecular pump says that no, I don't want a rotary pump for some reason, because my chamber which is sitting above me wants right from the beginning oil free. If that oil free constraint is not there, I don't mind using rotary pump, which is better than this pump, but otherwise I will use this pump. In order to use this pump, if necessary, turbomolecular pump can be added to another drag stage, so that it can come to the acceptable levels of vacuum like 10 torr, 10 millibar or something, where good enough amount of backing pumping speed is available with the diaphragm pump. So, these stories we will discuss as time passes, not only in this lecture, later also when we go for process applications. Typical pumping speeds are also limited, 200 liters per minute maximum pumping speed. They are all very lab scale pumps type thing. They can handle small quantities of gas. There are other diaphragm pumps which can handle huge quantities, we will see later. As compared to mechanical pumps, these dry pumps use very special quality of diaphragms, special quality of materials inside, because there is no lubrication. You have to be very careful. You have to handle things at high temperature if required. All that will be there, and the rotor and stators are not touching each other. So, how do you get compression expansion? There will be leak across that gap, which is a clearance between a rotating member and the stator. But that does not matter, because we are creating such a small gap which is of the order of mean free path. So, back flow may not be there. Even if it is there, front forward flow is much higher. All these concepts are there, and at the expense of all these things, we still prefer these things, because the semiconducting industry or pharmaceutical industry wants dry pump. But if you are having lubrication, the same lubricant will also act like a sealant and coolant. So, it is better, but we cannot afford to use it. Okay. These are the challenges in certain clinical applications or some food applications or semiconducting applications. They are high tech. So, typical pumps looks like this. There are several manufacturers who manufacture these things. and very high quality inlet and exhaust valves like that diaphragms are very important of the inlet exhaust valve, that called leaf seals, and main diaphragm which is doing the purpose of diaphragm vacuum, that is also important. What is the material you are going to use? Okay. So, a lot of material science is involved in every aspect, otherwise after 10 days, 15 days it will not work. So, that is how you should be careful. So, what is the construction? Like any pump, first you try to understand construction. You can see the left side, it contains a diaphragm, where is my, okay, it is here. So, this contains a diaphragm clamped here, diaphragm clamping with the housing and the piston connecting rod here, and this piston is connected to a eccentric cam attached to a shaft which is attached to a motor. I need not explain this further because any engineer can easily understand. It is a axial thing here. This is the central axis and cam is eccentrically situated. So, when the shaft rotates, because it is coupled to motor, there will be some sort of orbiting type of motion of this cam. Once it is orbiting, this connecting rod will have a rocky but linear motion. That means, it will go up and down, at the same time it will be rocky left and right type thing. A rocky linear motion I call it, you can call in any way, and this creates the diaphragm up and down and little tilted this side or tilted that side. Depending on whether you are sucking, then it is preferable to make it nearer to the inlet valve. This is my inlet valve, and if it is exhausting, this is my exhaust valve. Okay. So, inlet valve, exhaust valve, then connecting rods, diaphragm, clamping disc, and cam, eccentric cam and shaft. Okay. I am not going to read these things, you can go through that and understand properly. It is like any other thing, no, it is like a piston and cylinder type of attachments, etc. Okay. The connecting rods all are similar to our IC engines or any mechanical things. And how this compression and expansion is taking place? If you look at the figure, the expansion and compression is taking place because of up and down motion of the piston, that we will see now. Okay. Look at the figure. Concentrate on one stage, basically it is a two-stage compressor sort of thing, because it is also compressing from a vacuum level all the way to atmosphere. This is my first stage, identical second stage will be there. These two are connected by interconnecting pipe, and finally it is exhausted to atmosphere. Mind you, this does not require any other helping hand to exhaust to atmosphere, it can directly exhaust. And single stage cannot create very good vacuum level, but if you are interested in 200 millibar, you can use single, otherwise you will have to use double. When you are using double stage, you should see to that the exhaust of the first stage should be connected to the inlet of the other stage. So, while this piston is moving down, the piston should go up. They can be connected to a common shaft and with the various couplings, you know how it is done in a typical engine that is used in automobiles. So, this sort of thing you can easily generate that type of motion. Now, you concentrate. This is a two-stage pump. This is inlet valve is slightly opened and the gas from the chamber of your interest, whether it can be a chemical reactor or it is a backing of a turbomolecular pump, or initially bypassing the thing and evacuating a chamber using a dry pump up to 1 tar. So, that gas is coming here. Inlet valve is opened because of pressure difference, because this piston is going down. So, there is a partial vacuum created. So, the valve, it is just a diaphragm, another diaphragm, a small leaf seal, it opens because of pressure difference and molecules start getting sucked here. And when the pressure difference is very small compared to this bending, then what will happen? The valve closes. That is called this isolated volume. both inlet and exhaust valves are isolated now. Now onwards piston moves up, so there will be compression going on and a pressure will come where the exhaust valve starts opening till this goes to the top dead center with a finite small volume. If you make this finite dead volume as small as possible, you will get better and better compression ratios, and this is connected to the next stage inlet. So, these two will go in a alternative way. While it is going, this piston is going down, other piston will go up. So, this periodic movement of this diaphragm will cause the space between this diaphragm and the housing vary. So, that way you will have expansion and compression, and that will create evacuation of the chamber and exhausting through the other port like any other machine. Okay. I hope it is clear, but of course, in literature you can go for a lot of animations, you can get a feel of it, but it is almost similar to the machines that we regularly see in our day-to-day life. Only thing here is diaphragm. So, this volume is below the diaphragm is totally isolated from the above diaphragm, because below the diaphragm is having lots of lubrication, it has got crankshaft, everything. That is like any other engine. They may have lubricating oil and various rings, sealings, etc. All that, cooling attachments, cooling again, fins, all those things are there. But pneumatically, this chamber which is doing work when it is coupled to the motor is not connected to the actual process chamber where suction and compression are going on. Okay? This is what I want you to understand. That is why it is called dry pump based on diaphragm. Now, the real challenge is how to choose this diaphragm in spite of thousands of times it is up and down, deflections are going on, it is not tearing off. Similarly, the valves, very small pressure difference, it should be able to open. So, these are the challenges. So, only very good companies like Vacuum brand, etc., they have mastered this technology. Okay. When you try to do, principle is simple, but the materials, they are fiber reinforced composites of typical structure, compatible to vacuum, and even of lakhs of cycles, they will not get torn, that springy action will be there in the walls. Similarly, here in spite of several motions and also rocking motion, the diaphragm will not get punctured. That is the beauty of it. So, inlet port of the first stage, when it is coming down, this volume is connected to the inlet port, the piston is coming down, this volume starts collecting the gas molecules. After that, what happens? The inlet valve is closed, exhaust valve is also closed, then you try to compress it. I am telling this again and again, because once you are clear with this constructional aspect and action, then you will start understanding, okay, very small volumes only I am compressing. So, pumping speed is not much, very little pumping speed, that is all, but it is a dry vacuum. Okay. So, you have to capture the gas during the motion in the downward motion of the piston, and you have to isolate the gas, then you have to again compress it, and while that time in synchronization with the inlet and exhaust valves. Okay. And how, when it is opening, exactly at that pressure, the pressure difference is such that the forces are opening inlet and exhaust valves, and when the exhaust valve of this stage is opened, the other valve is exactly opened, when this is closed, that is opened. So, this mutual exclusiveness, etc., of first stage, second stage, or for the same stage inlet and exhaust, these have to be worked out properly, and the suitable materials have to be chosen. In the long run, the reliability of the materials are very important, and it is worth doing, because we are getting a dry vacuum right from 1000 millibar to 0.1 millibar, 99.99% is removed without any oil lubrication in the working volume. In the rotary pump, in the working volume, there is a lubrication. Okay. So, you should understand like that. You can look at the figure, sort of animation is there. So, inlet valve is opened, molecules are coming, and again diaphragm is going up, volume is reducing, pressure is increasing, exhaust valve is opened, like that, and that exhaust can be connected to the inlet of other pump. Okay. And it can produce only 10 millibar or so. Compression ratios are not much, but with the 2 stages maybe you can go up to maximum 1 millibar or 0.5 millibar, like that. But they are ideal for UHV applications. They are also ideal for molecular distillation or wherever contamination is not allowed. They are ideal for semiconducting applications. No impurities are allowed. Who knows, some of these hydrocarbons, they make it the device P type or N type. We do not know. We have to add parts per million impurities in an intentional way, in a calculative way, not from spurious way. So, the hydrocarbons will act like a contamination which will affect the quality of the device. It will also affect the quality of drugs as well as even the food items. We cannot accept hydrocarbon or oily smell even if it is very small quantity. Okay. So, pumping speed is shown here with inlet pressure, it drops heavily by 1 millibar. So, most of these pumps are ideal for 10 millibar. If you want to make a good backing pump to a turbomolecular pump, there must be additional stage of turbo drag pump, so that whatever is the typical exhaust of a turbomolecular pump is 10 power minus 1 molecular flow, no, that is turbomolecular pump, but that will be further dragged to bring it to 5 millibar or so. Around 5 millibar there is a finite pumping speed of this diaphragm pump. Sometimes people say dry membrane pump. So, that way there will be continuous matching of the backing of the turbo pump to the front side suction of the ultra high vacuum chamber meant for semiconductor applications or X-ray tube applications or plasma applications, fusion applications or space technology applications or even metallurgical things, etc. Okay. Molecular distillation. So, this is how the pumping speed variations of a typical diaphragm pump look like, and this is a ready made unit. Inside there will be diaphragm pump, and it is typically used for even medical and pharmaceutical applications mainly, where you can use it for drying, distillation, filtration, etc. And as I often have been telling you in this class, that real application of this diaphragm pumps initially for backing of the turbo pumps, and parallelly they have got lot of applications in pharmaceutical sectors where oil traces are not allowed. But there are other competitors like scroll pump, etc. for backing applications nowadays, and there are other pumps like claw pumps and screw pumps. They are also dry pumps, and they compete with these pumps in the form of huge pumping speed. They can also produce 0.1 torr without any oil traces. If necessary, they can produce little better vacuum using a booster, but their pumping capacities are quite high. So, that way they can be used in pharmaceutical sectors where dryness is required. Dryness should not be confused for water free, it is not like lubrication oil free. We may use it even to suck water vapors, but we have to see to that the pressure conditions are such that inside the pumping chamber it has not reached the saturation pressure. So, saturation temperatures even with heating effects or whatever goes on inside, so that two phase is not there, and water vapors coming from the reactor go all the way at the exhaust. Such precautions have to be taken. Okay. So, they are used, they are ideal for dry applications in pharmaceutical sectors where oil free vacuum is required. Okay. You can go through these advantages, and some limitations always will be there. Okay. What are the limitations? This diaphragm is exposed to mechanical fatigue after some time, but that should happen once in a year. Every now and then if you have to change these diaphragms and you are not an expert in that, and downtime will be more. This is exactly the problem these diaphragm pumps are facing. Okay. That people are trying to overcome, because there is a lot of research going on in these materials of composite materials which are used as seals and diaphragms, which can withstand a lot of cycles. Okay. That way, material research and optimization, properly designing and using it for a particular high-tech application, making a cost-effective analysis of it, and competing with the other dry pumps. So, it goes on in the subject. So, the first pump we have completed today, a diaphragm pump, which is a dry vacuum pump. Next we will see claw pump, that is also dry pump. Later we will see screw pump, and at the end we will see scroll pump. And then we go for again dry pumps, but that time they are dry, high, ultra high vacuum pumps, they are called turbo pumps and cryo pumps. So, now onwards we are not only going towards high and ultra high vacuum, we are also going into clean and cleaner technologies, because high tech technology quantitatively they want very low molecular density, fine, but qualitatively also they want certain chemical signature of that residual gas. So, there will be residual gas analyzers continuously monitoring these things, what is coming from the pump, what is coming from the process, whether it is something is acceptable or not. Okay. If it is very hot gases are coming, you may have to add some pre-condensers to these pumps, so that those gases will not come into the pump. Okay. Sometimes process condensers right in between the pump and the chamber, or between two pumps are required, that is interstage condensers and all. All these things are vacuum technology applications in process industries. We will see that again, and that time we will talk about dry pumps versus wet pumps and selection criteria of pumps, etc. So, with this let us conclude this diaphragm starting point of dry vacuum technology in the medium vacuum level. Thank you very much.